Okay, so let us start today. Today we will start again with some problems. First question is so that a signal xt is equal to exponential of j omega 0 t is periodic and its fundamental period is 2 pi by omega 0, and fundamental period is 2 pi by omega 0. Okay, so the first thing that we need to observe that what is our signal. Here the signal is xt is equal to e to the power j omega t0, and it is a complex exponential signal, right? Okay, so and our task is to show that it is a periodic signal and its fundamental period is 2 pi by omega 0. So the thing is that xt is equal to e to the power j omega t0 is periodic for or rather we can write if e to the power j omega 0 t plus t0 or t plus capital T is equal to e to the power j omega 0 small t. Okay, or we can write it e to the power j omega 0 t multiplied with e to the power j omega 0 capital T is equal to e to the power j omega 0 small t, which indicates that e to the power j omega 0 capital T is equal to 1. Fine. Now, when it is possible that it is 1, the value of e to the power j omega 0 capital T is equal to 1. If omega 0 is equal to 0, or if omega 0 t is equal to m into 2 pi. For m is positive integer, m is a positive integer, this condition will be satisfied, right? So for non-zero omega 0, we are getting omega 0 t is equal to m into 2 pi. Hence, t is equal to m 2 pi by omega 0. So the fundamental period will be 2 pi by omega 0, right? Is it clear? Okay. So first we have proved that it is periodic if this value is satisfied. That means e to the power j omega 0 capital T is equal to 1. If this is satisfied, the given signal is periodic. And it is possible for omega 0 is equal to 1 or omega 0 t is equal to m into 2 pi. So hence it is clear that it is possible that this signal is periodic. And now we have calculated the fundamental period. Okay. So its fundamental period is 2 pi by omega 0. Now we will go to the question 2. Again, a signal is given xt is equal to cos omega 0 t plus theta. Question is, so that it is periodic. And the fundamental period is 2 pi by omega. So you people please see the answer of this question and try to solve this one. Okay, so the question is xt is equal to cos omega 0 t plus theta, so that it is periodic and its fundamental period is 2 pi by omega 0. Okay, please take 2-3 minutes or 3-4 minutes and try to solve. If it is solved, then please match your answer with my answer, and if you cannot, I will solve it for you. Please look into the answer of this question and try to solve it in your copy. Take 2-3 minutes. If anyone can solve it, please try. At least all of you try to solve. It should not take more than 3-4 minutes, right? Take 2-3 minutes and try to solve. It is not that much tough. Please take 2 more minutes and try to solve. So those who have just joined, for those we have solved a question xt is equal to e to the power j omega t, j omega 0 t, and we have shown it is periodic and its fundamental period is 2 pi by omega 0. This is what we have done till now, and the signal is a complex exponential signal, right? Now we have a cosine signal xt is equal to cos omega 0 t plus theta, and we have to show that it is periodic and its fundamental period is 2 pi by omega 0. So please look at this answer, the answer of the first question, and try to solve by yourself the second question. Both are similar type question, right? Take one more minute. If you cannot solve, then I will solve it for you. Okay. If anyone have solved it, match your answer with my answer. Okay. So this signal cos omega 0 t plus theta will be periodic for if cos omega 0 t plus capital T plus theta is cos omega 0 t plus theta. If this condition is satisfied, then this signal will be periodic. So we can write it the signal, or rather xt is periodic. Okay, someone please, hello, someone please tell me, have you received the notes of previous session? Anyone who joined previous session, last week's session? Okay, all the notes will be shared with you. Okay, and probably you already have received some link where all the notes and recordings are uploaded. Okay, so xt is periodic if this condition holds. So what we can write, so we can write cos omega 0 t plus omega 0 capital T plus theta is equal to cos omega 0 t plus theta. Okay, this is theta. Okay, okay, and this condition holds if omega 0 t capital T is equal to m into 2 pi, right? So, or we can write T is equal to m 2 pi upon omega 0, right? For m is positive integer, positive value integer, right? Okay. So what will be the fundamental period? Fundamental period is for m is equal to 1, that is 2 pi by omega 0. So the fundamental period omega 0. Fine. Now we will go to the question 3. Again we will consider a complex exponential sequence. The first question was complex exponential signal. And now we will take a complex exponential sequence. What is the difference between signal and sequence? Signal is continuous in domain. Okay, and sequence is in discrete domain. Okay. So given xn is equal to exponential j omega 0 n. This is given. So that this is periodic so that xn is periodic if omega 0 by 2 pi is rational. This is the question. So now it is your turn to solve this question. Again, this is simple. The earlier two questions was about two periodic signal. Now we have taken a periodic sequence, but everything will be similar. Please take 2-3 minutes and try to solve. If anyone can solve, please raise your hand. Okay? And if you cannot, just wait. I will solve and match your answer with mine. Okay? If anyone cannot solve, I will solve it for him. But at least you should try to solve. Please take 2-3 minutes. It is in same manner, but in same sense you can solve this in same method in which method we have solved the earlier two problems in similar way. Take 2 more minutes and try to solve. At least one of you should solve this problem. Take 2 more minutes. In the similar manner, you can solve. Okay, so let us solve now. So this sequence is periodic. X1 is periodic if e to the power j omega 0 n plus capital N is equal to e to the power j omega 0 small n. Okay, so we can write it like e to the power j omega 0 small n multiplied with e to the power j omega 0 capital N is equal to e to the power j omega 0 small n. So we will get e to the power j omega 0 capital N is equal to 1, right? So this will hold. And when it is possible? It is possible. This happens when omega 0 capital N is equal to m into 2 pi, where m is positive integer again, right? So omega 0 by 2 pi is equal to m upon capital N is equal to rational number. Okay, fine. If it is not rational number, then it will not be periodic. And that type of example also we will see in upcoming problems. To question 4. Question 4 is xt is equal to cos 15t. Okay. Find the value of sampling interval Ts such that xn is periodic sequence. Question is, it is very important and interesting question. Find the value okay rather question part A of the question. find the value of sampling interval Ts such that x of n is equal to x of n into Ts is periodic. So this is the question, and very simple question. Again, you people first try to solve. Take 2-3 minutes and try to think that in which way we can solve this problem. And then I will solve it for you. Okay? Take 2-3 minutes or 4 minutes. Take 1-2 minutes more and try to solve this question. This is similar way we can solve, like it is related to question 3. Okay, it is very interesting problem and related to question 3. In the manner of question 3 we can solve this. Take 1 or 2 minutes more and try to solve. If anyone solve, just raise your hand. If you cannot, I will solve it for you. Take one more minute. Anyone who has solved? At least one of you. Okay. So let's try to solve this problem. Okay. This is very simple question. The fundamental, first we will calculate the fundamental period of xt. 2 pi by 15, right? Because omega 0 is 15. So this is fundamental period. Now xn is periodic if if ts upon t0 is equal to m by n0, where m and n0 are positive integers. Okay, so or ts is equal to m upon n0 into t0, or ts is equal to m upon n0 multiplied with 2 pi upon 15. It is what we have to calculate, right? Now there is another question, part B of this question. This is very simple. Part B, find the fundamental period of xn. Find the fundamental period of xn if Ts is given zero point 0.1 pi. Okay. So hope you people can solve this problem. You take 1 or 2 minutes. This is nothing of just 2 minutes problem. Everything is given, Ts is given. You have to calculate fundamental period of xn. That means n0. From here, using this, you can calculate. We know the relationship between Ts and n0. Ts is given, n0 we can calculate. And for fundamental period, m will be 1, right? I have given the hints also. Now you people take 1 or 2 minutes to solve. If you cannot, I will solve it for you. Okay.
Twenty.
Yes. Okay. So let us try to solve this problem. Two things we have to notice. First, it is given that Ts value is given to us. So we can calculate n0. And it will come with an expression of m. Now the thing is, normally m is 1 for the fundamental period, but we have to check the lowest value of n for which the n0 will be an integer, right? So okay, let us solve it, then you can understand it in better way. Using this formula we can write Ts is equal to m upon n0 2 pi upon 15 n0 is equal to m upon 0.1 pi into 2 pi upon 15, or n0 is equal to m 20 upon 15. Okay, or n0 is equal to m 4 upon 3. Now we have to check that for what value of m it is an integer. So lowest value is 3. The smallest integer n0 can be lowest integer value of n0 is 4 for, in bracket we can write m is equal to 3. So the fundamental period is 4. Four. Okay. Okay. Now we will go for question 5. Before that, please see the answer. Okay, question 5. X1t and X2t are two periodic signals with fundamental period T1 and T2. T1 and T2. So under what conditions the sum is also periodic? x1t plus x2t is periodic. So this is the question. Please see the question and try to understand what is asked and try to think in which way we can solve the question. It is important that before going in the solution part, you should understand the question first. So take 1 or 2 minutes to understand the question. This is very crucial and important question. Because solution is very easy here also. You take 1 or 2 minutes. You take 1 more minute and try to understand the question and try to find out the way of solution. Then we will try to solve this. Okay, so let's try to solve. It is given x1 is periodic. So x1t t plus m t1 x2t is equal to x2 t plus, let us write k of t2. Okay, now let us consider that xt is periodic with period t. With period capital T. So x of t, we can write first x of t is equal to x of x1 of t plus x2 of t, and we already have, so x of t is also xt plus tau or t plus capital T, which is x1 t plus capital T plus x2 t plus capital T. Okay, is equal to x1 t plus mt1 capital T1 plus x2 t plus k of t2. So we can write m of capital T1 is equal to k of capital T2 is equal to capital T, or T1 upon T2 k upon m is equal to rational number. Okay, so this is the solution. Please look into the solution and try to understand what we have done. Then we will proceed in further question. You people please look into the solution and try to understand. Take 2-3 minutes. Okay, so I hope you have understood all the questions till now. Now we'll proceed further. Determine whether the following signals are periodic or not. A xt is cos t plus pi by 4. This is the given signal. Our task is to find whether it is periodic or not. If it is periodic, we will also try to find the fundamental period. Okay, so let's solve. This is very simple question. So you people will take 1 minute to try to solve this. And if you cannot do, I will solve it for you. Okay, so let us write it in such way that we can write xt cos t plus pi by 4 is equal to cos omega 0 t plus pi by 4, where omega 0 is 1 Okay, so it is periodic and fundamental period. So xt is periodic with fundamental period. T0 is equal to 2 pi by omega 0 is equal to 2 pi. Fine. Okay. Next, part B of the question, again determine whether the signal is periodic or not and find the fundamental period if possible. This is also very simple question. Xt is equal to sine of 2 pi by 3 into t. You people please try to solve it. Take 2-3 minutes and try to solve it by yourself. If you cannot do, I will solve it for you. And if you can solve it, just match your answer with mine. Okay, take 2-3 minutes. It can be solved in the similar way of previous question.
Time period is 3.
Yes. Anyone? Okay, so let's solve it. Anyone else? So we can write it xt is equal to sine 2 pi upon 3 t is equal to, we can write sine omega 0 t with omega 0 is 2 pi upon 3. So first part was whether xt is periodic or not. Yes, xt is periodic. With fundamental period t0 is equal to 2 pi upon omega 0 is equal to 2 pi upon 2 pi by 3 is equal to 3. Fine. Now we will go to the question part 3 or part C of the question. C is xt is equal to cos pi by 3t plus sine pi by 4t. Again take 3-4 minutes. It is little complex than previous one. So take 3-4 minutes and try to solve. Then I will solve it for you.
Twelve.
No, not 12. Maybe 12 also. Let me check.
24.
Yes. Yes. 24 may be solution. Let me check. So first one is cos pi by t pi by 3t, right? So let us name it x1t or this is x2t. So x1t is cos pi upon 3 t. So the fundamental period will be T1 is 2 pi upon pi by 3 is equal to 6. Okay. X2t is equal to sine pi by 4t. So T2 upon pi by 4 is equal to 8, right? Okay. So T1 by T2 will be 3 by 4, and which should be a rational number. So the fundamental period is T0 is equal to 4 T1 is equal to 3 T2 is equal to 24, right? Fine. Now part 4. It is a very interesting question. Xt is equal to cos t plus sine root 2t. You can take 3-4 minutes and try to solve. It is very interesting question. Take 2-3 minutes or 3-4 minutes and try to solve. If you cannot, then I will solve it for you. But at least you should try. Take 2-3 minutes more and try to solve. Take 2-3 minutes and try to solve. It is very interesting question.
This is note rational numbers.
Yes. So let's solve it. Again, let us consider x1t. Other students, please try to solve also. So x1t is cos t. So fundamental period t1 is equal to 2 pi. x2t is equal to sine root 2t. So fundamental period t2 is equal to root 2 pi. How it is coming? 2 pi upon root 2, right? So t1 upon t2 is equal to 2 pi upon root 2 pi is equal to root 2, which is not rational. Which is irrational. So xt is not periodic. Okay. Next question. It is also a very interesting question. xt is equal to sine square t. Please try to solve. Take 2-3 minutes, even more, because it is important and interesting question.
time period is pi.
Yes. Anyone else who can solve this? Take 2 more minutes, other students. Okay, so let's solve. Xt is equal to sine square t. So sine square t we can write half of 2 sine square t. So and 2 sine square t means 1 minus cos 2t. So it will be ultimately half of 2 sine 1 minus cos 2t. So it is basically half minus half of cos 2t. So this is x1, this is x2t, this is x2t, x1t is equal to half, which is a DC value, right? So it can be periodic with any arbitrary period. x2t is equal to 2 pi upon 2 is equal to pi. So xt is periodic with period pi. Okay. Now you will see all the questions for 1 minute each question. Total 5 minutes you take and to understand what we have done in these questions. Then we will proceed further. Five minutes you take to see the questions and then we will proceed further. Five questions are there, 1 minute each. Okay. If there is any doubt, you can ask. Then we will solve some interesting questions.
DC component is periodic or not?
Which one?
क्या DC component periodic हो सकते हैं?
Yes, DC component is periodic of any arbitrary period. It is always the same value, right? So if you consider any arbitrary period, it is true that that DC component is periodic for any arbitrary value. Because everywhere it is giving same value. If DC component is not periodic, then this is not valid. 2 more minutes, you check all the answers. Okay, so our question it was 6. We'll go to question 7. Prove n is equal to 0 to n minus 1, a to the power n is equal to 1 minus a to the power n upon 1 minus a for a not is equal to 1 and n for a is equal to 1. We have to prove this. First, you people try to understand what is the question, then try to solve it. You people take 2 or 3 minutes, try to understand the question and then try to solve this, then I will solve it for you. We have to prove this, right? Take 2 or 3 minutes. The second part is very simple. If n is a is equal to 1, then we will get the summation n, because n times 1 is getting summed up, right? But what about the first part? If a is not 1, how can we prove it? So try to solve. Take 2 more minutes and then I will solve it for you. Okay. First we will start with for a is equal to 1. It is simple n, right? Because from n is equal to 0 to n is equal to n minus 1, total n number of 1 is getting summed up directly. We can write 1 plus 1 plus dot 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 plus 1 is equal to n. Okay, now for n not is equal to 1, the main question here, if n not is equal to 1, let us assume it is equal to 1 plus a plus a square plus dot 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 a to the power n minus 1, right? Now a into s will be a into n is equal to 0 to n minus 1 a to the power n is equal to a plus a square plus dot 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 plus a to the power n minus 1 plus a to the power n. Now we will subtract this from this. Now if we subtract this from this, then we will get a minus s minus as. That means 1 minus a into s, a minus as. That means we will get 1 minus a to the power n. How? Because if we subtract this from this, we will get this. So s is equal to 1 minus a to the power n upon 1 minus a. S was the sum we have considered and we have proved this, right? For a is equal to 1 this, for a not is equal to 1 this. We have very less time left, so we will simply go to the next problem. Probably it will be the last problem. Okay, you people please take 1 or 2 minutes to understand this first, because in the next problem we need this one, the concept of this one. Take 2 minutes or 3 minutes to understand. take 1-2 minutes more to understand this. Okay, so let's come to the second question. Prove n is equal to 0 to infinity a to the power n is equal to 1 upon 1 minus a for a less than 1, model less than 1. Okay, we will go simply in the solution. For this, limit n tends to infinity n is equal to 0 to n, or n minus 1 we can write, a to the power n, not n, small n. Limit n tends to infinity 1 minus a to n 1 minus a. If a is less than 1, that means this will be 0. So we will simply get 1 upon 1 minus a. Okay, so let us end here today's discussion. We will continue next day. The recordings will be shared with you.